Hey everybody, happy Wednesday. No Zoom Wednesday. Doesn't mean you're not learning though, right? Everybody's working hard. And we are working hard today on another math warm-up. Okay, looks like there's some more diamonds there, more exponents, and a little review of the perimeter and area, right? We did earlier in the year. And this question over here, what is the range of your answers? What that means is on these 9 exponent problems, I want you to figure out what the range is, okay? So go ahead and copy down all these diamonds, copy down all these exponents. This goes in your math folder. Copy down these 3 rectangles and their measurements, right? 3 meters, 8 meters, 30 inches, that's a square, 6 centimeters, 21 centimeters. Copy all those down and then give yourself a spot where you're going to have the perimeter and the area. The perimeter and the area. We're just going to use P and A for those 2 measurements. Okay, and see if you can figure out these diamonds. Remember, the answer on top is the product of these 2 numbers, and the answer on the bottom is the sum. Okay, go ahead and pause this video, copy these things down, and then try them, and then come back and check your answers. Okay, I'll see you in a bit. Welcome back. Okay, so many of you recognize that this is what they call a perfect square. The same number times itself equals 36. I mean, I know 4 times 9 is 36, but 4 plus 9 is 13, so that won't work. I know 3 times 12, because that's 3 dozen, right? Or 3 feet, inches, right? Equals 36, but 3 plus 12 is 15. So what works here is the 6 and the 6, right? Similar, I know 6 times 4 is 24, but 6 plus 4 is 10, not 11. I know that 10 plus 1 is 11, but 10 times 1 is 10, not 24. What works here for both? 3 times 8 or 3 plus 8. And remember, it doesn't matter if you mix them up and have 8 times 3, because 8 times 3 is the same as 3 times 8, and 8 plus 3 is the same as 3 plus 8. What word in math describes that? Commutative. Good. Commutative means that it doesn't matter what order you do multiplying or adding in. It does matter with subtracting and dividing, right? Okay, 28 and 11, what 2 numbers work there? A 7 and a 4. 7 times 4 is 28, 7 plus 4 is 11. And what works for the 63 and the 16? 6 plus 3 is 9. 9 goes into that, right? Remember, all the 9's less than 99. Add up to 9, the digits. 6 plus 3, just like 3 plus 6, right? 4 times 9. So 7 and 9 on this one. Most popular wrong answer for 3 to the second power is 6, but we know the problem is 3 times 3, and that's 9. And 3 to the third power is not 9, it's 3 times itself. How many times? That many times. So 3 times itself 3 times, which is, these 2 became 9. 9 times 3, 27. And when you do these in order like this is not 12, right? This is 3 times itself 4 times. When you do these in order, you can pretty much take all the work you've already done. So I know that these 3 are going to make 27. 3 times 27. You can come over here and do the standard algorithm if you want. But I want to show you something else. 3 times 7 is 21, and 3 times 2 is 6 plus 2, 81. I want to show you, remember how we say multiplying is commutative? Okay, that means you can kind of do it in any order you want. So let's say I did these 2 3's and got a 9, and these 2 3's and got a 9, and then multiplied those 2. What did I get? 9 times 9, 81. Still works, right? Kind of cool. All right, 4 to the second power. What's the most popular wrong answer there? You said 8, you're correct, right? 8 is the most popular wrong answer there. The correct problem is 4 times 4, which is 16. 4 to the third power is not 12. It's 4 times itself that many times. So it ends up being 16 times 4. That's 4 10s and 4 6s, right? 4 10s is 40. 4 6s is 24. 40 and 24, 64. And 4 times 4 times 4 times 4, and I want you to do it the same way we did it the second time, right? For the 9s, I want you to do 4 times 4 and get 16, 4 times 4 and get 16. Why did I want you to do that? Yep, you guessed it, 16 times 16, 256. Now, if you know that by heart, but you don't know 6 times 7 yet, that's a little silly, right? Go practice those facts. Remember, you can get con minutes for your practicing your facts this week, this quarter, this semester, right? All right, 5 times 5 is 25. And if 25 is a quarter, and I have 5 quarters, I have $1.25. And you can keep going in order like we did the first time, or do it like this the second time and say, what is 25 quarters? Or you could say 5 times 125. That's $5 and 5 more quarters. $5 is easy, it's $5. 5 more quarters is another $1.25. So 5 times 125, or 25 times 25, ends up being $6.25. Now, that last question, what is the range of your answers? What's the range again? Right. The difference between the biggest and smallest. How wide are those numbers spread apart? If I put the smallest on one end and the biggest on the other. Well, the smallest is way over here, 3 to the second power, 9. The biggest is way over here, 5 to the fourth power, 625. What is the difference? What the difference is, the answer to a subtraction problem. 15 minus 9 is 6, and 61 minus nothing. So 616 is the range between all those 9 answers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, perimeter. I'm adding up all the way around. If I start here, I go up, I get 3, then plus 8 more is 11. That's not the perimeter. I only went halfway around. Mr. Shebes used to say the farmer's building a fence around the field. That's your perimeter, the fence problems. And when you see fence problems in the book, it's almost always perimeter, okay? So 3 plus 8 is 11. That's halfway around. Another 3, another 8 ends up being 22 meters. And how do you get the area of a rectangle? You just multiply the two, right? I have 8, right, columns of 3, or I have 3 rows of 8. 3 times 8 is 24. And what kind of meters are those? This is important. Square meters. And you can put a 2 up there to signify square meters. We'll talk about why, okay? And again, you could have drawn your lines and say, I'm going to divide this into 3 rows, and I'm going to divide this into 8 columns, and then counted the squares. How many squares are going to be? Well, 24 square units. Okay, back to this. 30 and 30 and 30 and 30. 120 inches is the perimeter. And 30 times 30, that's a basic fact, right? 3 times 3 with 2 zeros. 900 square inches. Again, I'm doing that. You're going to learn why that works later. Okay, 21 times 6, that's 6 20s and 6 1s. 6 20s is 120, 6 1s is 6, so that's going to be 126 square. Some people write the square like that, SQ. Some people spell it out, square centimeters. You can do it like that. The perimeter, 6 plus 21 gets me halfway around. Another 21, another 6 gets me the rest of the way. 27 plus 27, perimeter should be 54 centimeters. All right, good job on that warm-up today. Don't forget to log some con minutes or practice those facts, all right? All right, we will see you later.